Okay, so we're going to talk about plate tectonics. This was the warm-up from, I believe was it Monday? Yeah, Monday. So the first thing about plate tectonics we're going to look at is continental drift. Evidences for continental drift. A theory, first of all, continental drift was a theory that is proposed. It's the idea that continents have moved horizontally to their current locations. It was developed by Alfred Wegener. Wegener believed that all of the continents were connected as one large landmass. He called it Pangaea. So he's the one that coined the term Pangaea. Some evidences include fossils of mesosaurs that have been found in South America and Africa. Glacial deposits and grooved bedrock were found in southern areas of South America, Africa, India, and Australia. And then parts of the Appalachian Mountains in the eastern U.S. are similar to those found in Greenland and Western Europe. So how could the continents drift? Well, the rock, fossils, and climate clues were the main evidences for continental drift during Wegener's lifetime. Wegener's theory was often rejected because no one could explain how the continents moved. So this made it hard for scientists to really accept his reasoning that the continents were drifting rather than just simply moving up or down. Now, one thing that I want to make sure that you guys understand is, and actually I was watching a video about this last night, laws can never be truly proven. You know, when we start talking about things like evolution and continental drift and, you know, plate tectonics, these things are never really proven. They can only be disproven. But, you know, there's a lot of evidence out there for continental, for plate tectonics. There's a whole lot of evidence out there for it. But, you know, last night I was watching a video, I think Veristerium had it out to where, you know, there's something called, there's the idea that you really can't, and you can't tell, the physics for an object is the same in a mirror compared to out of the mirror. And it wasn't until the 50s that they found out that, no, it is different for some particles. So, and then they came back and they said, well, there's some other things that would be the same in a mirror that's not. So, you know, sometimes these laws are later found out to be untrue. And at that point, once they're found out to be untrue, they're no longer laws and they're completely put off to the side. So the theory of plate tectonics, again, it is a theory, which means we do have a lot of evidence that points to it, but, you know, there's no way to absolutely prove it. So the theory of plate tectonics is the idea that the Earth's crust and upper mantle are broken into sections called plates that move around on the mantle. So, you know, you remember we've talked about this before, and you're going to look at it again. Composition of the Earth's plates include the lithosphere, which is the crust and the part of the upper mantle, the asthenosphere, which is the plastic-like layer below the lithosphere. So let's go on. That one that we watched a while ago was from yesterday. So this is today's note, or Wednesday, December 13th. So plate boundaries. There are 3 different plate boundaries. A divergent boundary. So diverge means it's going to separate out. You're going to diverge from something. Convergent boundaries. Well, converge means to bring together. And then a transform boundary, which means they're going to transform in some way. So let's look more deeply into this. So a divergent boundary. Divergent boundaries are boundaries between 2 plates that are diverging or moving away from each other. So you can see here we have 2 plates being formed. You're actually getting landmass right here being formed, and it's moving the plates. They're spreading them apart. So you got diverging boundaries. Convergent boundaries are boundaries that that exist between 2 plates that are converging or moving toward each other. There are 3 major types of convergent boundaries. First, there's the ocean floor, the situation where an ocean floor plate collides with a less dense continental plate, so that's ocean continent. And then you have an ocean floor plate colliding with another ocean floor plate, so that's ocean. And then you have a continental plate that collides with another continental plate, so that's continent. So here we have the 3 different types. We have oceanic continent, then we have oceanic, and continent. So, you know, you see different examples of this, and that's part of your project you're going to be doing today, is looking for examples of not only these 3 types, but also divergent and transform. Let's look at transform. So a transform fault boundary, sometimes they're called faults. Perhaps you've heard of the San Andreas Fault. That's an example of it. It's probably the best example that we have in America. So transform fault boundaries are boundaries between 2 plates that are sliding horizontally past one another. And this is where you hear a lot about earthquakes and this and everything. You know, there was a big one. I want to say it was in L.A. Back in the early 90s that really did a lot of damage. Okay, so the effects of plate tectonics. Well, landforms caused by plate tectonics. So there's rift valleys. This is caused from divergent boundaries. There's mountain ranges, like what's in Colorado, continental convergent boundaries, and there's volcanoes can be caused from oceanic continental convergent boundaries, and there's faults, and faults are caused from transform boundaries. So let's just take a look at convection currents. Remember one of the first assignments I had you guys working on is looking at the convection currents in a pot of boiling water, and you could see how it was just moving like, you know, in this pattern right here. Whoops, let me go back. So you could see that, there we go. You can see that the water was moving in this manner. So whenever you start looking at the mantle, these patterns exist. But it doesn't just happen here. As the mantle semi-liquid material heats up, it moves off in that direction. Then you might have some over here and moves off in that direction. Then it starts to cool back down, and these two move back. So in this case, whatever land forms up here and whatever land forms up here is going to be pushed together like that. Okay? So you're going to have some kind of a convergent boundary, and then maybe next to it you might have some convection currents that go like this. And now you've got landforms being moved this way, or plates being moved this way, and now right in this area you're going to have a divergent boundary. So, again, convection currents is the driving force of plate tectonics in which hot plastic-like materials from the mantle rises to the lithosphere, moves horizontally, cools, and sinks to the mantle. The convection currents provide enough energy to move the plates in the lithosphere. So let's just review this again. What kind of boundary is this? What kind of boundary do you think this is? And finally, what kind of boundary do you think this is? Okay, so now you're going to go on to the Plate Boundaries project. You're going to find this again below this on the projects page, and I'm going to go over it just a little bit with you. Let's see if I can find it. Here it is. Okay, so you're going to be using probably PowerPoint or slides, doc slides, to create this. You can do a poster, but just make sure you're doing your research today, which means you need to go out and look for pictures, look for explanations. So first of all, obviously, you're going to need a title. You're going to have your name. Okay, this is the Plate Tectonics project. You can be creative with the title. You're going to go over a divergent boundary. You're going to need to define it. You're going to need to draw a diagram of it or have a diagram of it. You can also, and in fact I would suggest heavily, to have a picture of a divergent boundary. Something that you found online would be great. Then you need to have examples what occur at this boundary. Then you need to have a transform boundary. Again, define it, diagram, same thing. And then you're going to have the convergent boundaries, 3 different types: continental, oceanic, and oceanic. Here are some different sites you can go to. And again, this particular page is already copied and pasted into Classroom, so you guys can take and look at it and refer back to it so you know how to do the project. Okay. Well, thank you, and I hope you have fun doing this. It is due Thursday, so you have 2 days in class, today and tomorrow.